linear speed of points, angular speed of bodies using the relative velocity formula, which I'll introduce, and then I'll show you two methods of using that formula. So a brief overview of concepts. Okay, so the equation, the relative velocity formula is something we have done in the past. I wrote this equation down maybe 2 lectures back. Velocity of a point B is velocity of point A plus velocity of B with respect to A. Okay, so it's saying that if there's a point A and another point B, then you can, if you know the velocity of A, you can find the velocity of B, provided you know velocity of B with respect to A. So what is velocity of B with respect to A? It is simply the angular speed crossed with the position vector from A to B. So A to B, the vector is this way, and this body has an angular speed omega. Okay, so if you want a physical interpretation of this, I just tell it to you quickly, but the book does a better job of telling this. The equation there tells you basically velocity of B. So you can actually break down velocity of B as it is composed of two parts: velocity of A plus omega cross RB with respect to A. The first part, velocity of A, is actually the translational motion of A. Okay, the contribution due to translation of the body. The second part is due to rotation. So you can actually think of motion of any rigid body as translation and rotation. First part is the translation part. Second part is the rotation part, assuming that the point A is fixed. Okay. That's the intuitive explanation. You should go to the book and read more about it. We'll be using this formula again and again to solve for linear speeds and angular speed. There are two ways of solving the problem. One is what I call the vector mechanics way. So two ways of solving problems. One is what I call the vector mechanics or the analytical equation. So what you do in this method is write VB, VA, omega, RB with respect to A as vectors, right? So velocity of B, and we are only looking at planar motion. So velocity of B has some I component, some J component. You write that as a vector, right? Velocity of A, write omega and RB with respect to A. That's the first step. Second step is you compare I and J components on both sides. Okay, and then what will happen is you'll see that invariably in such problems there will be two unknowns because you'll be generating two equations. So that is two equations. Solve for the two unknowns. So you'll never see that this problem has more than two unknowns. If you have more than two unknowns, you'll have to set up another equation, compare and go and so on. So it'll be clear once I solve a problem. But that looks like one equation, but that's actually two equations because that equation has an I component and a J component. So that's one way of solving problems, and I'll solve this using this way. So if that was confusing, it'll be clear once I solve problems. So the other way is Scalar Mechanics, or the book calls Pictorial Way. So again, we look at the equation in a slightly different way. So I'm going to write the equation first. Okay, the first step is write the magnitude and direction for each component. So that would be for VB, VA, and omega cross RB with respect to A. So once you do that, the second step is write two equations, one for X component and one for Y component. The third step is solve for the two unknowns. Okay, an example would be when you looked at motion under gravity, you knew the velocity, you knew the angle, right? So you wrote V cosine theta is the velocity in the x direction, V sine theta is the velocity in the y direction. Similarly, for VB, try to write the magnitude and direction. So we'll draw arrows. For VA, we'll do the same thing, and for the last component, we'll do the same thing. And then we'll compare the x components on both sides, y components on both sides, which is actually the same as comparing I and j, but some people prefer it doing this way. And once we do that, we'll see that we'll have two equations for two unknowns. We can solve for two unknowns. So we'll put all this into practice by solving problems. Okay, let me just, I think the first two parts, that part sometimes is confusing. Omega cross RB with respect to A. Let me tell you how to compute that easily. You can actually write I and J and compute it, but here is an easy way of writing this part, or rather solving for that part using the pictorial way. Okay, so omega cross RB with respect to A. What is that? So A is this, B is this point. The vector from A to B is RB with respect to A. Okay. So this is a line on the rigid body, and the rigid body is spinning at a certain rate. So let's assume that spinning at the rate of omega. Okay, where omega here I've shown it counterclockwise. Okay, now the question is, what is this vector on this figure? Can you show what that vector would look like? What is the direction of the vector? Turns out that that vector is normal, right angles to this vector. That's true because omega is, how do you get the direction of omega? Well, you curl your right hand along omega, your fingers curl along omega, your thumb gives the direction of omega. So its omega is along k. Okay, because we assume that k is points outside the plane of the paper. If you try to do omega cross RB with respect to A, that is this vector, omega is coming out of the plane. The vector A to B is this way. So in order to do omega cross RB with respect to A, you need to curl your fingers from omega to the vector B with respect to A, and your thumb gives the direction of VB with respect to A, right? Which means that the direction is going to be this way. So you do not have to do all that thing. You don't have to find omega and b with respect to a. The easiest way of figuring out the direction is first look at the vector from a to b. It's this way. With that points the direction of the vector. Just turn that vector along omega. So if omega is going this way, you turn the pen. I'm going to turn the pen this way, and that gives me the direction of VB with respect to a. That's also true if omega was the other way. If omega was pointing inside the page, then it would be clockwise. So take the vector and turn it along the direction of omega turn. So in that case, I need to turn the pen this way, clockwise, and this would be the direction of VB with respect to a if omega was pointing inside the page of paper. So you do not have to actually write that equation. You can just use this simple trick. Find the vector a to b and turn it in the direction of omega. So omega is counterclockwise, turn it counterclockwise, 90 degrees. That's the direction of VB with respect to a. If it's this way and the angular speed is clockwise, turn it clockwise, and that gives you the direction of VB with respect to a. So this is turn RB with respect to a by 90 degrees in the direction of omega. Okay, and it's always 90 degrees. Remember that. Okay, so given all that, let's.
So otherwise, we just solve it through matrix, right?
Yeah. Otherwise, the other way is clearly, if you think that's too hard, write omega as omega k, and RB with respect to a as whatever in terms of I and j, and then you can cross. That's absolutely fine. Okay, first problem. If the roller A moves to the right with a constant velocity of 3 meters per second, determine the angular velocity of the link, okay, and the velocity of the roller B at this instant. Okay, so if we know that if A is moving to the right, B is probably moving down, and the link AB is rotating counterclockwise. We know that from intuition. However, you do not have to know that. You can start assuming that velocity of angular speed is positive, is clockwise. And let's assume that velocity of B is this way. Okay, we know that's not the right direction, it's downwards. But here's the thing, if you assume it in a different way, you do the math, it'll actually come out to be negative of what it is, which means that it's going to be in the direction downwards. So you do not have to guess beforehand if the velocity is in this direction, that direction. Just assume something. I'd like to assume positive direction. So since my j-axis is upwards, I'm assuming velocity of b is upwards. Okay, and you'll see that it'll actually come out to be negative, which means it's actually downwards. So let's try to solve for VB and omega using both those methods. So the first method is vector. Okay, I'm trying to write velocity of B is velocity of A plus omega cross RB with respect to A as vector. So velocity of B, well, I assumed it to be upward, so it's going to be the magnitude of velocity, which is VB, and we know that it can only go up and down because it's a roller. Velocity of A, we've given that it's 3 meters per second to the right, so that's 3i. And finally, we need to find omega cross RB with respect to A. Okay, we assume that omega is counterclockwise. Okay, so if you curl your fingers along omega, the thumb gives the direction of the vector omega. That vector is obviously k, right? If I is to the right, j is upwards, then I cross j is k. That points out of the plane. So omega magnitude times k. Okay, now we need to find the vector from A to B. This way. So we know that vector makes an angle of 30 degrees with the x-axis. So 1.5 is the length. Cosine of 1.5 cosine 30 degrees, right, gives me the component in the I direction, and 1.5 sine 30 degrees give me the component in the j direction. I only need to put in the sign for those. So if I take this vector and I resolve it in the x direction, you can see it points along the negative y-axis. So it should be negative 1.5 cosine 30. And if I take the y component, it points in the positive j direction. So it's going to be positive here and negative here. So 1.5 omega cosine 30 degrees k cross, it should be I, k cross I plus 1.5 omega sine 30 k cross j. Okay, so to find k cross I and k cross j, there are multiple ways. One is you can write a matrix I, j, k and find that. Here's a simpler way of doing it, and which I prefer, which is, in order to find this, what I'll do is I'll draw a circle, I'll write I, j, k, okay, such that it is, so I, j, k is in the counterclockwise direction because I know I cross j is k. So when I take I cross j, I need to go traverse in the counterclockwise direction. So that should give me k. If I go from j to k, it should be I. So j cross k is I, k cross I is j, and so on. So if I were to find k cross I go from k to I. So the direction is positive because counterclockwise, and k cross I is clearly j. So this should be j. For this one, I need to go from k to j, but I need to go clockwise. So that should be negative. So negative I. So this comes out to be minus 1.5 omega cosine 30 degrees j minus 1.5 omega sine 30 degrees I. Okay, so putting all this together, well, actually, is actually minus 1.3 omega j minus 0.75 omega I. Okay, so now we are ready to write the equation VB equals VBJ equals VA. VA is 3I minus 1.3 omega j minus 0.75 omega I. Okay, this comes from 1. Okay, now we need to compare both sides. Compare I. So the left side there's no I, so 0 equals, there's a 3 and there's a minus 0.75 omega on the right. And then we need to compare j. That's going to be VB equals minus 1.3 omega. That's it, right? So what we notice is that we got two equations and two unknowns, omega and VB. You can solve for omega using the first equation, sub that value in the second equation, and solve for VB. VB is minus 5.2 and omega is 4. So that should be meters per second. This should be radians per second. Okay, as I told you, velocity of B, we assumed it to be upwards, but that's not true. It's downwards. We know that from intuition. and the sign came out to be negative, which means that our intuition is right. It should move, B should move downwards. And the assumed direction for omega was right. It was counterclockwise. So that's one way of doing this. The second method is the scalar method. So what we do is we try to write this equation as an equation of magnitude and direction. Okay, so velocity of B is in the y direction, that's upwards. Velocity of A is in the x direction, so that's to the right. And omega cross R B with respect to A, so that's going to be, I'm going to write that as omega cross R B with respect to A. Note that I wrote magnitudes. The first time was magnitude, magnitude. Right? I need to write the direction of omega cross RB with respect to A. So here's where you can use the trick which I told you, which is if you want to find the direction of omega cross RB with respect to A, what you need to do is take the vector from A to B. So the vector points from this way, right? And turn it by 90 degrees in the direction of omega. So in this case, I need to turn it by 90 degrees. So it will point downwards. So in other words, this is the vector B with respect to A. That makes an angle of 30 degrees. The vector VB with respect to A is going to be at 90 degrees. So it makes an angle of 60 degrees with the horizontal. So this vector is going to be at 60 degrees. Okay. So we're all set now to, so now what we need to do is equate the x components on both sides, equate the y components on both sides. The x component, let's take the y component. Okay, the y component is on the left side is VBY. Vx is only in the x direction, so there's no contribution. Omega cross RB with respect to A, well, we know it's at 60 degrees, so I need to take that, resolve it along the x-axis. So if I take that vector, resolve it along x-axis, it's going to be omega. It's going to be the magnitude of omega times RB with respect to A. So omega times 1.5, because 1.5 is the length of the ladder, times cosine of 60. So 1.5 omega cosine of 60 degrees. Similarly, the x component, by the way, this should be a negative sign, right? Because that arrow, the x component is pointing to the left, the negative y-axis. Similarly, the x component is, well, the left side is 0, right side is VAX, and the x component, oh my bad. That is wrong, right? Should have told me. It should be sine. I'm trying to equate the y component. So this is actually the x component. That's not right. It needs to be the y component. So it's going to be sine of 60, and it's going to be in the direction which is downward. So it should be sine of 60. And then VAX is going to be cosine of 60 degrees in the negative. So it should be minus 1.5 omega cosine of 60 degrees. Okay, so again, two equations, two unknowns. From the first equation, solve for, this is 3. Okay, from the second equation, you can solve for omega. And from the first equation, you can get VBY. Yeah, this is not right. This should be positive. Okay, now it looks right. So omega will be positive, counterclockwise, and VBY will be negative. So you'll get the same answer basically. VBY will be minus 5.2 meters per second. Omega would be 4 radians per second. Okay, so these are the two ways of solving the problem. Now you may prefer one over the other, so feel free to use either of the way. That one is very straightforward. As long as you're comfortable with vectors, you can do that. If you're more comfortable trying to visualize it, if you're a visual person, then you might want to do it this way. But both should give you the same answer. They actually test you on multiple things related to relative velocity. Just like the relative velocity formula, there's an acceleration formula too. So something like this, there's a very good chance you'll see in the exam. So you want to pay special attention and do well in such problems. Okay, if the block C is moving downwards at 4 feet per second, determine the angular velocity of AB. So that is an unknown. And that's about it. So you're given length and you're given velocity of one single point. Okay, so in the interest of time, I'll only be able to solve it using one method, but my notes, I've done it both ways, so I'll post my notes where I do it both ways, but I'll solve it using the vector method, okay? And then you can try to do it with the other way, scalar method. So if you know the velocity of C, we need to find velocity of angular velocity of AB. Something else we know that the velocity of A is 0 because the point A doesn't move. We also do not know the velocity of BC. In fact, we'll see that we'll actually get angular velocity of BC when you solve this problem. Okay, so the vector mechanics way, we need to write velocity of 2 points using the formula. So let's start off with C. So velocity of C is velocity of P plus omega, I'll call that omega BC crossed with R C with respect to B. So I know what the velocity of C is. I know the magnitude and direction, so I can write that. I do not know anything about velocity of B. I don't know the magnitude as well as the direction. I do not know anything about omega BC. I just know that it is either pointing outside or inside the plane. And I know what the vector B to C is. So this equation has 3 unknowns, and I can see that without even writing the equations. It's going to be 2 unknowns in velocity of B, the magnitude and direction, and the magnitude of velocity of BC. So 3 unknowns, 2 for velocity of B and 1 for omega BC. So I cannot, if I set up this equation IJ, I will not be able to solve for 3 unknowns because that equation can only give me 2 equations. So what I'll do is I'll try to relate VB with VA now and see if that helps me. So velocity of B is velocity of A plus omega AB crossed with R B with respect to A. So let me put 1 and 2. Get VC equals VA plus omega AB crossed with R B with respect to A plus omega BC crossed with RC with respect to B. Okay, let's see if we can now solve this. So we know the velocity of C, magnitude and direction. Velocity of A is simply 0 because A does not move. We do not know the magnitude of the velocity of AB. We do not know the magnitude of angular velocity of BC. We know the vector from A to B. We know the vector from B to C. So right now I have 2 equations because it's a vector equation, and there are 2 unknowns, omega AB and omega BC. So I should be able to solve for both those unknowns, 2 equations, 2 unknowns. So now let me try to set up the various things in that equation. So Uh, I've already shown the axis. Sometimes you're not shown the axis, in which case you have to assume a certain axis. Without axis, we are not able to grade you, right? So be sure that you show the axis. So velocity of c, we can see that c is moving downwards, so it's going to be negative 4j. Okay. Omega AB. Now the question gives you the direction of omega AB. It's saying it's clockwise. So clockwise is negative. So I'm going to write it as negative omega AB. Okay. Omega BC. We're not given the direction of omega BC, but let me just assume it to be counterclockwise. And if that's wrong, then the math will tell me if that's wrong. The direction assumed is opposite of what it should be. So let's assume that to be the direction of BC, omega BCK. Next, I need to write the vectors A to B and B to C. So the vector from A to B, the magnitude is 2. You can see the direction from A to B is what? Is it plus I or minus I? The vector from A to B goes this way. That's positive I. And then I need to write R. The vector from B to C. So B is there, C is up. So I need to find the vector which is at 30 degrees to the x-axis. So the magnitude is 3. I need to resolve this vector in the x direction and the y direction. So the x direction is cosine of 30 degrees I. It's positive because when I resolve that, it's pointing in the positive I direction. Similarly, there'll be plus 3 sine 30j. Okay, so given all this, I'm now in a position to put that in equation 3. So that's first part. Second part is cosine 30 is 0.866. Sine 30 is half, so 3 times 0.5j. Okay, so k cross I plus 3 times 0.866 is 2.6. K cross I, and then 3 times 0.5 is 1.5, so plus 1.5 omega BC k cross j. Okay, so I can now use this trick. I j k so k cross I, to go from k to I go counterclockwise, so that should be positive j. K cross I is positive j, and k cross j, to go from k to j, I need to go clockwise, so it's going to be negative I. So given that, I can write this equation as 4j equals minus 2 omega a b j plus 2.6 omega b c j minus 1.5 omega b c I. Compare I and j gives me minus 4 equals minus 2 AB plus 2.6 omega BC, and 0 equals minus 1.5 omega BC. which means that clearly omega BC is 0. So 2 equations and 2 unknowns. You get omega BC is 0 from the second equation, and if you put that in the first one, you get omega AB is minus 2. Well, plus 2, sorry. Okay, so that is solving it one way. I'll post my notes where I've solved it the other way too. Is this clear? It's very straightforward once you set up the equation. Okay. I'm going to move on.